And welcome to the next lesson, which is Transformations, Part 3. We're doing reflection today. Reflection I personally find a bit more intuitive and easy to grasp than rotation. So hopefully this lesson, even though it's quite a few pages, hopefully it's going to be pretty quick and easy for you. So to start with, just reminding you of what reflections are kind of based on. They're based on basically mirror images. So in these memes below, can you draw in approximately, because we can't do it perfectly on these pictures because they're not structurally drawn correctly, but they're photographs. So draw in approximately where you think the mirror line would be on each of the memes below. So on the one with the lion, I'll draw it in yellow. So the mirror line, roughly kind of like about here could be the mirror line. It's fine. Basically the mirror line is over which line is kind of reflected. So if you reflect the little bear in the mirror line, you'll probably get its image in the water. If you reflect the lion in the yellow mirror line, you'll approximately get the lion's image in the water. The baby, mirror line is kind of like roughly here. So just showing you can get mirror lines in all sorts of directions. You can get them in vertical and horizontal, in diagonal directions. They're all over the place, these mirror lines. And they help us to see how to draw the mirror image. So in 2015, 2016, the VHS school year was all about reflection. But have you ever considered reflection in the form of transformation in geometry? So in this lesson, you'll need to be familiar with certain types of lines which will be used as mirror lines for reflection. So commonly used lines as mirror lines in reflection problems are the ones I've got in colour here. So to start with, so that you can understand what those lines would look like on a coordinate plane, let's practice drawing them in. So the x-axis, let's draw that in red. So the x-axis, quite often they'll ask you to reflect an image across the x-axis, meaning that the mirror line is the x-axis. So I'm just going to do them freehand. X-axis is in red. So use your colour coding, use a red pen or pencil or something to draw in the x-axis in red. Done. The y-axis in blue. So the y-axis is blue. Y-axis is blue. So whatever colours you use, you can recode it if you like. The line y equals x in green. So I'm going to do the line y equals x in green. So y equals x would have a y-intercept of 0. And its gradient is 1. So it means from the y-intercept, go across 1, up 1. Go across 1, up 1. Or up 1, across 1, same thing. Across 1, up 1, across 1, and so on. So you can go down 1, back 1, down 1, back 1, down 1, back 1, and so on. And then just draw a straight line through those, which I personally find a little bit difficult to do freehand. So you should use a ruler to do yours too. X and Y axis is pretty easy. Okay, so just neaten that up. Here's the line y equals x, which I've done in green. The line y equals negative x, let's do that in purple. So it would have a y-intercept of 0 again, but it's negative x, so it means going down 1 across 1, down 1 across 1, down 1 across 1, down 1 across 1, and so on. From the y-intercept you could also go up 1, back 1, up 1, back 1, up 1, back 1. Because the rise over the run is negative 1 over 1. And now let's draw our line through there. Oh dear. Shall I use the line tool, sorry? So I'll fix that. So y equals negative x. So there's our line y equals, you can label them too if you want, if you've got the space. I've kind of colour coded them so to some extent they're labelled. So for example, you could label this one y equals negative x. You could label this one y equals x. The x-axis and the y-axis are already labelled, they've got x's and y's on them and arrows anyway. Now we're doing the yellow one. The line x equals 2 in yellow. So is that a horizontal or a vertical line? If you forget, try imagining what a line would look like if it cut through the point x equals 2. And yep, you probably got it right. It's a vertical line. Let's do a vertical line. Drew x equals 2. I might label that just for reference, so when I look back on it, I can see what it is. X equals 2. Done. And in brown, it's the line y equals 2. So y equals 2, if you cut through the point y equals 2, right there, oops, cut through the point y equals 2, would it be a horizontal or a vertical line? That's right, it would be a horizontal line. So let's draw a line through there. I find a nice brown. No, I don't like that brown. No. Okay. So go back to y equals 2, and let's label that y equals 2. Ooh. Okay. Okay. Y equals 2. Done. So those lines, this would be a good reference for you to look back on. Quite often these are the lines that in transformation reflection problems, these are commonly used as mirror lines. So it could be any like horizontal or any vertical line. It doesn't have to be x equals 2 or y equals 2. But commonly horizontal and vertical lines are used as mirror lines. The x-axis and the y-axis are common mirror lines. And the y equals x and y equals negative x are also commonly used as mirror lines. So question, what does the word equidistant mean again? Try to think. What does it mean? It just means equal distances from a common point. Something like that. Equal distances away from a common point. Because the word equidistant might be helpful here. Let's do an example. Just to point it out. E.g., say if we do this common point, we put it in black, common point in black, and in green, point A and point B. Notice these are equidistant. Equal distance from A and B, approximately. So they've got the same distance from the common point, which I've drawn in black. That's what equidistant tends to mean. So now let's move on to the next page and try some examples. So in the diagram below, the object, and the object is the original thing, has been reflected in the something to form its something. So you probably guessed, it's reflected in the mirror line. So the object is reflected in the mirror line to become its image. In this case, we might call the red shape the something image. Right, we can call it the mirror image. So because it's a reflection, we can call the red shape the mirror image of the object, which is the green shape. Notice also that the mirror line is in here. So the mirror line is the something something of the line segment from any point on the object. If you remember from coordinate geometry, a thing that kind of looks like the word in green, it's the perpendicular bisector. So notice that the mirror line is the perpendicular bisector of the line segment from any point on the object to its corresponding point on the image. You might be wondering, what on earth does that sentence say? And understandably so. So what we can say is the mirror line, oh actually the diagram below will kind of actually help point that out. So we've got the object, B, point, and we've got the mirror line. It's not the mirror line, the mirror line is here through the centre. It's a lovely little mirror line. And we've got the image point, B dash. Notice that they are equidistant, each of these points are equidistant from the mirror line. That's what it's just pointing out. See, it's got the dash dash on it. Dash dash. So it's just saying that the red point, object point B, is equal distance from the mirror line compared with the image point B dash from the mirror line. So they're equidistant. That's what that sentence above is trying to point out. Similarly, below you see A. The distance from A to the mirror line is the same as the distance from A dash to the mirror line. Same thing, point C. The point C, its distance from the mirror line is the same as the point C dash's distance from the mirror line. That's all they're pointing out in that sentence. So here we've just tried to elaborate a bit on that. For example, point B and B dash above, so B and B dash, the diagram above are something from the mirror line. What was that special word again? Equidistant. Equidistant from the mirror line. Hence the term bisector. So that's why the word is called perpendicular bisector, because it splits the length from B to B dash, it basically splits it in half. So the mirror line is called a bisector because it splits B, the line connecting B and B dash, it splits it perfectly in half. So bisector means to cut in half. See this whole line from B to B dash, if you're not sure what I was talking about, then cut in half by the mirror line. See all that because I'm not yet. Also, the red dotted line, which connects the points B and B dash, forms a right angle with the mirror line. So it's saying that basically, see these little, that whole big line from here forms a right angle with the mirror line. That's all that's pointing out. Hence the word perpendicular. So that's why the mirror line is a perpendicular bisector of the line segment from any point in the object to its corresponding image. So that's that line there. So the mirror line is a perpendicular bisector of that red line that I've just drawn there. Same thing you'll see on this one. The mirror line, the blue dashed line, is the perpendicular bisector of that line there, connecting the original image point C and its image point. Same thing, that bisects that one. That's just something interesting to note. It means that when you draw your reflections, that you can use that as a way of checking. Like, is the mirror line the perpendicular bisector of the points that connect each point to its corresponding image? It's a way that you can double check you've got your answer right. Now let's try some examples. We are asked to reflect the following figures in the given mirror lines. So the mirror line, see it on my video, it's right there. This is easy peasy, so we like this kind of stuff. It's fun, it's easy. There's the object, like draw it in red, don't have to. The image, easy enough. If you reflected this across the middle line, this little point here would become here, this little point here would be here, this little point here would become there. See the mirror images of each other? This is good testing of our spatial skills. And then you can just look at it sideways if it helps. Are they mirror images of each other? Yes, they are. Fabulous. Second one, mirror line. These are nice and easy to do. And compared with rotation, it's much easier. There's our object on the left. Let's draw our image. So you can sort of also, you can use the points. You can sort of freehand draw it to some extent too. This is a pretty easy one. 3 point marks across. The size and shape shouldn't change, it's more just its orientation in space. That's what's changing. So you could have tried plotting the points, but this was a pretty easy one to do like that. This one's maybe not quite as easy to do like that. A little diagonal one. Drawing the image line might be a bit trickier. So this point here will correspond with that point there. This point here will correspond with that point there. That might be easy to do. We can connect up those lines. This point here will correspond with that point there. There should be a length. Kind of just a diagonal length across one box. This point here should correspond with that point there. It's again just a diagonal length across one box. And then notice from this point you kind of go across, just kind of like going up like this. So you're kind of just going up one line. This point will correspond with that one. See, it's kind of like 2 diagonal boxes up from the center. 2 diagonal boxes up from the center. So about there. Different ways you can kind of plot it. Have a look, see, does it make sense? If you look at it kind of diagonally, yeah, that does kind of form the mirror image. And just make sure each point, that the mirror line basically bisects each point on the object with its corresponding point on the image. That's something to double check. our next one. Nice little mirror line there. Lovely. Now let's draw the image. So we've got, obviously we're going to have a point here, we're going to have a point here, right there and there. So well. There and there. And then we need to go diagonally across one box. This one. Diagonally across one box to make this one. And from here we need to kind of, this one here will correspond with that point there. And we'll kind of shut out like that. That's easy enough. But do you know what common thing I forget to do? Forget to draw that one as well. Don't forget to draw the complete shape. Don't just assume that because it was part of the object's shape, that you shouldn't draw it on the image shape as well. There's our mirror line. Here. Mirror line through there. So again, so we don't forget, let's do that now. There we go, great. So those 2 points here and here already been drawn. This one here will correspond 3 boxes up, so we should go 3 boxes down from the mirror line to form that one. And just connect them all up. Use a ruler, don't do it for freehand like I'm doing. That's a little yuck. There we go, that's nicely done. Right the way top. There's a mirror line here. There's our lovely little mirror line. Now let's try drawing it. It's going to be a little bit harder than you think. So let's see the T. It's kind of in the center. So T is going to start about here. Has to be 1 box away and start there. And it's got to go up 2 boxes. And then this point here will correspond with that point there. The other side of the T will, top of the T will correspond there. So just look, see how they opposite. I'm going to do P next to that's easy. This point here will become like that point there. Down 2 boxes. And it's kind of like a little thing around there. The O is a little bit tricky. I'm going to go from here down to here, to here, to here. Hopefully yours looks a lot better than mine does. So always have a look at them. Turn sideways if you want, if that helps you to see. Look sideways at it. Yep, it's the mirror image of each other. Fabulous. So now we're getting into some slightly more complicated ones. They were kind of nice, intuitive ones, those ones. So find the image of the point A42 under reflection in the y-axis. So let's draw our mirror line. Our mirror line is the y-axis. Helpful to draw in that mirror line. Now let's plot the point first of all. I'm going to plot it in red because it's the object point. 42. 42, here it is. Here's our A. We need to reflect it. Here. Get this fixed now. So we've got the point 42. We need to reflect it across the y-axis, the blue mirror line that I've drawn. So if we reflect it in this, so it's 4 distant boxes to the left that we need to go. So we need to go to -4 and 2. And that's our A dash. So what it wants to do is plot that point, -4 and 2. Reflected in the x-axis. So the x-axis, this is going across here. It's our mirror line. It's the same point, so it's A, at 4 and 2. Where's our image point going to be? Reflected across the x-axis. I think it's going to be at 4 and -2. Equidistant. The line y equals x, what was that again? That's right, it's kind of like a line coming through here. -1, -2, 2, -2, -3, and so on. Oops. Very badly drawn. Please use a rule and draw yours properly. So we've got the point 4 and 2, same as before. Its image point will be reflected across here. So try to think it's like from here to the mirror line, from the red point to the mirror line is a diagonal box. So go across another diagonal box. So you'll end up here, A dash. So we're just asked to find the image. You could always point out what it is. They might ask for the, in case they ask for the coordinate, that's what you would do. So in this case, let's see, you would go just pointing out what you would write if they asked for the coordinate. -2. The coordinate of this one would be -4 and 2. Notice the answers are quite similar, but slightly different in terms of their sign. Last one, reflection across the line y equals negative x. So y equals negative x, kind of cutting through here. And we've got the same original point, 4 and 2, it's A. So reflect that across there. So another way of looking through at it is going from A down to the mirror line, we need to go back by 4, down by 2. So do the same going away from it to create this image. Go down by 2, across by 4. And that kind of makes sense, doesn't it? A dash will be hang on, have I done that right? Have I done that right? Double check. Maybe not. Yep, so we went down by 2, across by 4, then we went down by 2, across by 4. Okay, I think that's right. It's just hard to tell from my board is a bit warped. So if I have made a mistake on there, just because of the way the board being warped makes me look at it differently, then I will let you know. I'll put a little pop-up on here so that you can see what the answer should be. So if you disagree with me, please let me know. Oh, sorry, I did that wrong, didn't I? Negative 2, negative 4, that's not that coordinate. That coordinate is, hope you're paying attention, good, negative 4 and negative 2, both u x versus y. So hopefully that's the case. But yeah, again, because my board is slightly warped, it's slightly stretched in the vertical direction, it's making it really hard for me to see if I've done it correctly or just made a mistake. Okay, so let's just move on. And again, I'll put a pop-up if I've made a mistake. So keep an eye out for any pop-ups. Slightly easy one. On each of the diagrams below, label the mirror line with its equation. The mirror line's in blue. And then draw the reflection of the object in that mirror line. This is pretty easy. So looking at the first graph, it's a vertical line, so it's going to have the equation x equals something. It's just x equals 4. Easily done. You see how to reflect this one. So then each point needs to be equidistant. Please use rulers, don't do what I'm doing. I look so bad. Okay. Oops. I'm going to change the subject and then change colours. Okay. Not much better. Still, that's good. So what is the equation of the mirror line? In this case, it's a vertical line again. So it's just x equals negative 2. So it helps just do the points first. That helps keep you on track. And then notice I've kind of got to go back 3, up 3. Back 3, up 3. Because I noticed from the other one I went across 3, up 3. So back 3, up 3. Similar from the other bottom point, I need to go back 3, down 3. Do they match up? Yes, they do. Okay. Supposed to be mirror images if it was drawn with a nice ruler. Each point is equidistant with its image point compared with the mirror line. So the mirror line is down in blue. It's a horizontal line, so it's y equals. It cuts through negative 1. Not the easy one to draw. So you've got to go 2 points. So 2 points down from the mirror line. 2 points down from the mirror line for each one. Helps draw that now. And then 2 points from the point part on the left, right, go 2 points to the left and 3 points down. Similar to sort of what the one did above. Horizontal jump of 2 and a vertical jump of 3. Down, just check is each point on the object equidistant from the mirror line compared with its corresponding point in the image. Yes, it is. What am I going over there? I'm just looking that distance from there to there, same as that one from there to there. From there. What's the equation of this looking diagonal mirror line? And it's going across by 1, so it's going across by 1, down by 1, across by 1, down by 1. So it's y equals negative x. Good little baby. This one might be a bit trickier to draw. So this little point here will correspond with this little point here, would you agree? I hope you do. And then notice, from this little point you go across by 3. So similarly, we're going to have to go across by 3. That one's done. And then from that little point we went up 4 and across 1. So same thing, go down 4, across 1. and 4 across 1, and same from the other point at negative 4, go down 4 across 1. Or you could have just drawn the line from here to here. This is one where people could easily make a mistake. It's a little bit trickier. And then look at it diagonally if you like. Are they mirror images of each other? It's a good way that you can check your answer. Are they mirror images of each other? You might have picked up that no, they're not. So I have made a boo-boo. So let's start again. See, that little check is so important. So yeah, we're correct here. But noticing kind of like this point here needs to be equidistant from the line. So I sort of need to go sort of in the other direction. So I need to go cross 4 down 1. To agree, it's a bit more like this. Cross 4 down 1. Yep. So looking at it diagonally might help a bit more. And instead of going horizontally across from here to here, we need to go vertically across by 3 from here to here. Again, my board's warped, so it's kind of messing me up a bit. Sort of from here to here is 3, so from here to here we need to, instead of going horizontally, go vertically down like that. So see that little check that I did just really helped me to realise I've made a boo-boo. Again, because my board's warped, it really is messing me up, so I'm thinking it looks right, but it doesn't. But hopefully on the video it looks fine, because on the video hopefully it's not stretched at all. It's just on the smartboard it's slightly stretched vertically because of some kind of distortion in the projector. Okay, let's keep going. They're all done. Example. Last page. Find the image of the line y equals x minus 4 when it's reflected in the line y equals 2 and state the equation of the image line. Let's draw in the mirror line first of all. Y equals 2 and horizontal line. Oops. Vibration is getting a bit off. Here's our line, y equals 2. Now let's draw the original line, y equals x minus 4. It's got a y-intercept of negative 4. And its rise equals 1. And its run equals 1. Go up 1, across 1, up 1, across 1, and so on. And we need to draw a line through all of that. Up 1, across 1, and across 1. Came up reasonably okay. That's weird. Okay, next one. We need to just label that. So y equals x minus 4. And it's reflected across the line y equals 2. So its image, when it comes through the mirror line, the point's going to stay the same. That point's going to stay the same on the image. So then notice in the red line, we're going back 1, down 1. So instead go back 1, up 1, back 1, up 1, back 1, up 1, and so on. And then we can connect that up beautifully. Let's connect it up. And we can draw up this one. Let's connect that up. Let's go. And you can try to think what this would be. You could probably see just by looking at it that the y-intercept is going to end up being 8. Fair enough if you thought that. And the gradient, rise over run, is going down 1, across 1. So the image equation, because you know you're kind of going back 1, across 1, back 1, across 1, so you know it's going to end up hitting 8. So that's easy enough. If not, you could just sub in a point. So y equals mx plus c. You could work out the gradient and then you could try subbing in a coordinate to solve for c. But this one is just an easy one I can see. Y equals negative x plus 8 is the image equation. Because the question asks for it, that's why I'm doing that. So let's label that. Y equals negative x plus 8. How much time to do these ones before the class starts? So find the image of the line y equals negative 2x plus 1 under a translation of negative 1, 2, and then a reflection in the line x equals 1 and state the equation of the image line.